Okay, so second video on this one, limiting reactant question. Okay, so first thing was that we figured out how many mole of each reactant we had, and that was what we've got here. So you can just look at the ratio and try and figure this out, but if you get a bit stuck, what you can always do is just go back to the equation and think, all right, I'm going to look at this first reactant and I'm going to assume that all of it is going to be used up, and I'm just going to see if that is the case, how much lead nitrate I'd need, and if I have enough, is that possible? So if you get stuck, if you reach this point and you don't know what to do, just look at your first reactant and think, okay, all of this is going to be used up. How much lead nitrate would I need? Okay, so first part of this equation. Now, I'm going to assume that all of this is used. So this is my known value, and this is my unknown. Okay, take the first reactant, assume this is your known, okay? All of it's going to be used. This is your unknown. So what is our method for doing that? Well, our unknown is equal to our molar ratio, which is the unknown coefficient, which is 1 in this case, over the known coefficient, which is 2 in this case, times by the known value, which is 0.0157. So half of that, 0.0157 divided by 2 mole of lead nitrate is 0.008785. All right, do I have that in this experiment? Do I have that enough? Do I have that amount of lead nitrate? Look at this number. Look at that number. Do I have that much? No. So that can just tell you, if you answer no to that question, that's telling you that the lead nitrate is the limiting reactant. All of that is going to be used up before all of that is. This is going to be left in excess. All of this is going to be used up. So you use this value to work out how much precipitate you would get. Okay. You also use this value to work out how much potassium iodide would actually react with it. Now, just looking at the equation, for every one of these, double the amount will react with it. So the amount of potassium iodide that will react with this much will just be double. Okay, so the amount of potassium iodide that will react with it will just be double. And you could have used your molar ratio method to work that out. 362. That's how much will react. Okay? Now, if the question asked how much K potassium iodide is in excess, well, you know that lead nitrate is your limiting reactant. All of that's going to be used up. When all of that is used up, that much of potassium iodide is going to react. 0.00362. So in the beginning, we actually have 0.0157. That's how much we actually have of potassium iodide. This is how much is going to react. So the difference between those two is going to tell you how much is left over. 0.0157 divided by minus 0.0362, 0.01208. That's how many mole of potassium iodide is going to be in excess. Okay, the question doesn't ask you that, but sometimes it does. Okay, The previous video showed how I find the precipitate. Okay, you always use this limiting reactant mole value and then convert to grams.